Yeah, good evening all. I hope everyone doing fine in this pandemic situation. So welcome to this session. So today's session we will discuss both with the control of electrical machines and the fact devices controllers. And here we are sincere gratitude to the management of Y Mahabaleshwarappa Engineering College and prominently called it as a Vijayanagara Engineering College also, to the coordinators for giving this opportunity. Thank you. And about Pantech Solutions, you people will know about the established in 2004. We are working in different domains, workshops, faculty development programs, short-term courses. And here we are working on Internet of Things, artificial intelligence, embedded systems, TMS process, image processing, OpenCV, network simulation, power electronics, and electric vehicle. And for computer science and IT domain people, we are working on cloud computing, mobile computing, data and image processing, and Internet of Things, big data, data analytics. So in all these domains, we people are conducting workshops, webinars, and faculty development programs. Some trainings programs also we are organizing in association with the IETE Mumbai chapter and in association with the NIT Karnataka. We are weekly we are conducting some programs also, workshops, online workshops. And here the content, basic principle of the electrical machines, DC machines, synchronous, asynchronous machines, and the control of the electrical machines applications. Today we will discuss this content and fact devices controllers. So majorly fact devices controllers we can call power quality. Majorly why we need fact devices controllers means to improve the quality of the power we need some fact devices and fact devices controller also. Those devices also we will discuss. So in the fact devices majorly it will come shunt active power filters, active power filters, series active power filters, hybrid active filters, and DVR, UPKC, IUPKC, DStatCom, and various type of topologies are there. All those topologies comes under the power converter topologies only. So for controlling, we are to improve the quality of the power, we are using those devices. And here in this basic electrical machine, most of the people will know what is electrical machine. It is an objective which can convert the energy from one form to other form with the help of the converters. That means the converters, those are used to translate continuously electrical input to mechanical output or vice versa, whether electrical to mechanical or mechanical to electrical. So those type of machines we can call as a electrical machine. So the process in between, the process of translation is known as the electromechanical energy conversion. So Faraday is the father of this electromechanical energy conversion. Faraday's laws of electromagnetic induction principle only, right? Faraday's right hand rule, left hand rule, we people will know. So when we can call it as a motor, when we can call it as a generator. So whenever we people are converting the electrical energy into the mechanical energy, then we can call it is a motor, whether it's a DC motor or AC motor. So whenever we are converting the electrical energy into mechanical energy means, then we can call it is a motor. If suppose we people are converting the mechanical energy into electrical energy, we can call it is a generator. We can call it as a generator. So the types of the electrical machines, if the machines which are if the electrical system is AC means, so those machines we can call AC. If the machines those are using the DC power supply, so we have two power supply, AC power supply and DC power supply. So those machines which are using the electrical supply as input means those machines we can call DC, and those machines which are using the AC as the electrical supply means we can call it a AC machine. So here we have two type of machines, synchronous machines and the asynchronous machines in again in the electrical machine. So here the electrical machines mainly two electromagnetic phenomena in the electrical machines. When a conductor moves in a magnetic field, voltage is induced in the conductor. When a conductor moves in a magnetic field then a voltage is induced in the conductor. Otherwise, when a current carrying conductor is placed in a magnetic field, or when the current carrying conductor is moved in the magnet, when it cuts the flux also, then it will experiences some mechanical force here. When a current carrying conductor is placed in a magnetic field, the conductor experiences some mechanical force. So these two magnetic phenomena will be what? So majorly we have two type of motors, AC motors, DC type of motors. In the AC motors, we have the alternating current motors, direct current motors. So separately, if you are observing all over the globe also, for visually easily understood to the common people, inside of the machines, the cables and the rotor part, they are winding with some colors also. They are coding with some colors. Then the people will easily analyze which cable will give the high power supply, which cable will give the low power supply also. So then here AC motors and the DC motors. Here we have two types, synchronous and the asynchronous machine. Again in the asynchronous machine we have three asynchronous, we have squirrel cage type of machines and the slip ring type of machines also there. So in this slip ring and squirrel cage type of machine, squirrel cage type of machines they will perform better than the slip ring type of machines. And the DC machines we have separately excited, self-excited type of machines are there, series, compound and shunt type of machines. Different type of machines are available. So here we people will know well about the high power drives in all our vehicles. So in all the, whether it is a conventional energy vehicles, in all our vehicles all over the globe also, there we need one power drive, right? So to drive our vehicle, to move forward means compulsory we need one machine, electrical power drive we need. So in those type of machines, which type of machine currently going in the industry, real time industry, those people, which type of machines in we actually in our undergraduation level, majorly undergraduation level, we people will study single phase machines and the three phase machines we will study. So whether it is a DC or AC also we will study up to single phase and three phase. But in current situation, in UK government, so in their British naval ships, they are developed with the 15 phase type of squirrel cage type of induction motor drive in the naval ships, and they given the name also destroyer 2, they given the name for that way, for that naval ships. And now the United States of America also they are trying to implement 15 phase type of induction motor drive. Then you can imagine how much density it need when a motor is, then you can imagine how much power density we need to give to that type of motors. When range motor capacity, then how you are converting the energy from electrical to mechanical, or whether you are converting the DC to the energy, and how much power density you are given, then according to that the vehicle will be moved in high speed, right? If you are observing, if you are observing near to metro stations, or if you are observing the comparison between the electrical vehicles itself, electrical trains, if you are observing comparison in between the local passenger trains and the metro trains and the express trains. So the express trains, once they will start in the platform also, after crossing the up to crossing the platform, they will move with the less amount of the speed only. After crossing the platform only, they will try to increase the speed of the vehicle, right? But if you are observing the vehicles, the metro trains or passenger trains, within the fraction of second, these passenger and metro trains they will pick up in a high amount of speed. In platform itself, within 5 seconds or 6 seconds, it will take high amount of the speed. That means how much effectively working inside of the vehicle, the drive, motor drive only, right? Depending upon the motor drive only, it will take high amount of the speed. So how it will be operated with an high efficiency means, so it depending upon the how, whether we are converting the motors in series or whether we are giving the high power density at initially or not. So here all the vehicles also, they are, if any vehicle, so whether we are preferring the AC machine or DC machine also, if you are observing the basic structure of the electrical machine, basic structure of a electrical machine, when you are observing, that we have majorly two type of parts are there, stator and the rotor parts are there. The stator is covered, it will not move anywhere. The stator part, it does not move normally, so it is the outer frame of the machine. So whether whatever it may be, so whether DC or AC machine, it is the outer frame of the machine only, but inside of the rotor the machine will be moved. So the rotor part will be moved and the inner part of the machine, both rotor and stator also, they are made up of with ferromagnetic materials. Those machines, they are made up of with ferromagnetic materials only, they are made up of with. So here the rotor is always covered with the stator. If you are observing the DC machine, why not most of the industry people, they are not preferring the DC machines? The DC machines, compared to the DC machines, compared to the AC machines, DC machines will not come long life, and they doesn't give high efficiency and maintenance. So when you are purchasing a DC machines, you need to take so much burden to maintain, to operate that type of machine. So but if you are observing the AC machine, whether it is a synchronous or asynchronous machines, these machines have a rugged nature. These machines have a rugged nature. They have the robust nature, which automatically the supply will go to the stator part, and the stator part will be from the stator currents inside of the rotor, that currents will be produced inside of the rotor. Then some force will be applied to the shaft or torque of the motor inside of that one. So then only the motor will be rotate, right? So both are in the same speed only. So that we can call it as a synchronous speed. So these synchronous machines are primarily used as generators of the electrical power. That means most of the time we can use these synchronous machines in a thermal power station or a hydrothermal power station as synchronous generators we can utilize. We have synchronous generator and the synchronous motors also there. So these two things we can utilize as per our requirement. Synchronous generators are there, synchronous motors also there. The synchronous generator we can utilize in the thermal power. That means there we are converting the mechanical energy into the electrical energy. In a thermal power plant, we are sending the coal to the inside of the thermal power plant, then the crushes, then there we are converting the mechanical energy into the electricity, right? For that reason, there we are using the synchronous generator. These synchronous machines, they will generate the high amount of the power. They will high efficiency, within high efficiency, where we need the huge amount of the power. At that point, we can utilize these type of synchronous machines. In the pumps, in the generating station, electrical clocks, and the constant speed, where we need the constant speed. So in that case, we can use these synchronous type of machines. In the synchronous type of machines, you can see here, we are showing here a two-pole round rotor generator and the exciter. This is a synchronous generator only, two-pole round rotor type of, and the synchronous motors we can call as a power condensers also, power factor condensers also we can call. These are power factor compensators or synchronous condensers we can call. And here the round rotor machine, if you are observing the round rotor machine, here the stator is in ring shaped and laminated with the iron core and the slots. Here we have three-phase windings are placed in these slots inside of this machine, and the round solid iron rotor with the slots inside. DC current is supplied through the slip rings also. In DC current is supplied through the slip rings in a round rotor type of machine also. You can observe here, these are the real-time round rotor type of machines which are using for industrial. And here the salient pole we have in the salient pole machines, and the stator has laminated iron core with the slots, and the three-phase windings placed in these slots also. So here you can see here A, B, C we are mentioned, right? The stator has laminated with the iron core that is covered with, right? The rotor has salient poles excited by the DC current only, and here the DC current is supplied to the rotor through the slip rings and the brushes also inside of this salient pole or rotor type of machines. The slip rings will be connected to the current only, and here these are the salient pole rotor type of machines which are using in industrial applications. You can observe here, and here if you are coming to the induction machines, so we are majorly induction motors only. Most of the companies they will prefer most widely used electrical motors in both domestic and industrial applications. If that one we need to decide, but 80 to 90% of the industry they are preferring the induction motor only. The low and medium voltage application they are implementing the this compared to the slip ring type or wound round type of induction machine. This induction motor, squirrel cage type of induction motor, will give much efficiency, and compared to the cost issue also, the cost will be very less here due to the very less here. And if you observe the induction generator, due to the lack of separate field excitation, these machines are rarely used as generators. So most of the people, most of the industrialists, they will not use the induction generators. So they will prefer better than synchronous generators only. Most of the company people, they will prefer because they will work effectively compared to the induction generator. And here there is a drawback, lack of separate field excitation, but their exciter it will be work. So synchronous generators will work effectively compared to the induction generator. But compared to the synchronous motor or induction motor means most of the industry people they are preferring the induction motor. Wherever we need high power and means they at that point they are preferring with the induction synchronous machines also. And here these type of machines are rugged, mostly used in the industry, and they have both stator and rotor kind. But if you are observing both the difference between the synchronous machines and the synchronous machine, they have a small difference. That means synchronous machine they are running with the constant speed. That means synchronous speed. That means whenever you people are giving the supply to the stator of a induction machine, that means asynchronous machine, when you people are giving the supply, that induction machine, what will happen inside of the stator, it will be started to rotate, then rotating magnetic field will be produced, right? So rotating magnetic field will be produced. Through that a flux will be cut, rotating magnetic field will be produced, then it will be started to rotate with some synchronous speed. It will be rotated ns, it will be rotated with a synchronous speed. Then when the flux will cut, then magnitude induced EMF will be generated. Induced EMF will be generated means inside of the rotor machine the rotor currents will be activated. That rotor currents will give some force to the shaft or torque of the rotor. Then the rotor will be started with rotating speed nr. But nr is always, that means rotor speed is always trying to catch the synchronous speed. But in a induction motor, rotor speed is always less than the synchronous speed. If the nr is equal to ns means slip becomes to 0. That means both will be slip becomes to 0. Then there is no flux cut, there is no induced EMF, there is no current, there is no force will be to the motor. So it will goes to standstill condition or ideal condition. So that's the reason always in induction machines the nr will be less than the synchronous speed only, less than the synchronous speed. And here you can observe here the induction motor, all the industrial applications, so whether vehicle, these type of machines are highly reliable induction motor. And to control of the electrical machines, there are 3 steps are there: manual controller, automotive controller, by using the power electronics drives controller. So when we are implementing the power electronic switch through using the power converter topology under the automotive controller only, and the manual controller. So in olden days, how our forefathers will be operated this manual controller means by using the manual controller, starting and stopping and speed control of the motor had to be performed by hand every time. machines, when you are observing, here all our fathers will went to the near to agriculture farm, they are take with one spanner, right? So then through that they will start it to rotate, they will put some diesel or kerosene or they will put some regarding the motor, they will put some oil, right? So then they will start with the handle, with the handle they will start to rotate, then it will take so much time to start also. So to starting, stopping and speed control of the motor had to be performed by hand every time. If suppose we need to start with a heavy speed, that motor means we need to put more pressure on the vehicle. So through the belts, conveyor belts, olden days the people are using, right? So the operator had to move a manual switching devices from one position to another. And here the switching of large motors required great physical expert. So when we are thinking to shift these type of machines into a switching type of machines, so there we people manpower or physical effect we need to put more on this type of manual control. So the operator had to remain continuously alert to watch the indicators so as to adjust the motor performance according to the drive requirements. According to the drive requirement, the operator always need to monitor, he need to wait. Suppose if you have a 5 acres land in olden days, so then when you have started a motor or a machine means, then it will take so much time, right? So entire night you people need to wait. So whether in the middle of the time whether the motor will be stopped or not, you need to check. So nowadays which we people are using the AC machines, we no need to watch wait that much time. Once you are turning on the switch, automatically the power supply will go, the motor effectively will run. So here in this manual controller, the manpower we need required more here, and here the varied need of individual machines like frequent starts and stops, periodic reversal of direction of rotation, high starting torque requirement, constant speed, variable speed. Due to these various reasons, manual control have several disadvantages we have. So then everyone will be shifted to the power electronic drive related controlling technique or automotive controlling technique. Nowadays, every industry they are trying to shift automotive, right? So by using these power electronic drives controller. So what are the drive functions? So you need to vary AC or DC voltage electronically to control the speed, right? So suppose you need to control the speed of the motor. So by using the power electronic devices or power converter switches, you can easily control the speed of the motor or torque also, how much required unit. Whether you need to change the load torque, whether you need to operate with the load torque as per our requirement, or whether you need to rotate with the speed of the motor 1500 rpm or 2500 rpm or 3000 as per your requirement, and the drive functions you can easily operate. And the required commutation for AC motors. Suppose if you are going with the open loop DC motors or permanent magnet or wound round or induction motor, direct or inverters also. So here when you people or we people can control the machine means whenever we are giving the feedback path or closed loop, when we are giving the feedback path with the commutation, so then we can easily control the machines. So in the machines, those machines nowadays which are advanced version, brushless permanent magnet motors, induction motor with the field oriented control technique, brushless permanent magnet motors, more efficient, and these are compact and high speed. Nowadays most of the industry people they are preferring permanent magnet brushless DC motor. These permanent magnet brushless DC motor, those are AC type of machine only. They will work effectively, and at the manufacturing stage it will be somewhat very cost. But compared to the asynchronous, that means squirrel cage type of induction motor also, nowadays most of the people, whether water pumping system or industrial or agriculture purpose also, they are preferring with the brushless permanent magnet motors only. So these motors will give high efficiency, and the less ripples also, torque ripples also will be very less here. And here you can observe here the power circuit for a motor drives here will be converted into the AC into DC. Then here we are adding a three power electronics power converter. You people need to control the speed of the motor. Here I will show a simple model of a permanent magnet machine. So to control by using the power electronic switch, how you will control, I will show that model. Just a minute. Here the power by using the power converter or power electronic switches, you can easily control the machines. And here I will show some examples. Here the electric machines in the EV industry. So nowadays permanent magnets. So in real time industry, which type of machines the people are using? Permanent magnet synchronous machines in Nissan Leaf type of electric vehicle. Nissan Leaf type of vehicles, they are using the permanent magnet synchronous machines. Permanent magnet separately excited induction motors, they are preferring. BMW car companies, they are preferring permanent magnet separately excited induction motors. And the induction motors, squirrel cage type of induction motor, Tesla Model S type of electric vehicle cars, they are preferring. Switched reluctance type of motors, punch powertrain, NIDOC, these type of industry, they are preferring the switched reluctance type of motor. And the Tesla Model 3 type of vehicles, permanent magnet assisted synchronous reluctance type of motors, they are preferring here. And here we will see a small example of a BLDC example. So most of the people will know about the Matlab simulation, right? So Matlab is a vast topic, and it is like a ocean. So here in the Matlab simulation design, we can do all the analysis of our control of electrical machines. So you can see here, this is the Matlab command window. You can, if you give the command here, if you are observing, this is the command window, and this one is the workspace, and this is the command history, and this is the current directory path here. This is the current directory path, and this one is the current folder. Suppose if you need to all the mathematical, so all over the globe, more than 6,500 universities, they're working on for their technical or scientific problems, they are using the Matlab only. Matlab is not a open source, it is a licensed version tool only. And here in this Matlab also, we are preferring some toolbox. A number of toolboxes are there. As a electrical engineer, if you know the Simulink, Simscape, Sim Power System, then Fuzzy Logic Toolbox, Artificial Neural Network Toolbox, Control System Toolbox means it is sufficient to run or to develop your product or your as per your requirement, as per your research projects also you can easily implement by using the Matlab. So why this much? This is not a programming language. For initially we need to tell Matlab, it is not a programming language, it is purely based on the mathematical analysis. So when you are designing a motor, so whether you have the mathematical equation, how much wattage it will give, whether it is a 4 kilowatt motor or 1 HP motor or 5 HP motor, and how much input power density the motor need, all these things you need to analyze by taking the motor here. So here in this command window, whatever the variables if you are typing, all will appear in the workspace is here, and the command history you can observe all the things. And here I will show a closed loop controlling of by using the PI controller with the 3-phase inverter, how you are controlling the motor, how you are controlling, we will see here. Then we will move to the fact devices controlling techniques also, we will move. Here we will check here. Here a closed loop controlling of a motor, how we are controlling the speed of the motor, whether we are controlling effectively or not, all these things we will observe here. So here we are using a 3-phase inverter. The 3-phase inverter actually how many switches? It is a power converter topologies, right? And the 3-phase 6 switches we have. So how you are operating the switches? So how you are giving the gate signals? So if you are preferring a permanent magnet synchronous machine, as we said, nowadays most of the people permanent magnet synchronous machines, permanent magnet brushless DC motors are using. Compared to the squirrel cage type of induction motor, the people are preferring the permanent magnet brushless DC motor, permanent magnet synchronous machine. You can go for reference, you can go through R. Krishnan, IISc Bangalore professor. He written on the permanent magnet synchronous machines only. You can go through that book means, so then you will get more idea about the permanent magnet machines also. For permanent magnet brushless DC motor, we can run up to 10,000 rpm also. We can run up to 10,000 rpm also. We can run these type of motors, and advanced motors, advanced electric vehicle also, these type of motors only the people are preferring. So brushless DC motor or permanent magnet synchronous, it is not a brushless DC motor. A permanent magnet brushless DC motor, it is not a DC motor, it is a purely AC motor only. Inside of the DC motor, we will replace with the commutation and the brushes we will replace, then we are inserting with the permanent magnets. So in that permanent magnets, we are putting the Hall effect sensor signals. So Hall effect sensor signal will identify the rotor position. They will identify the rotor positions inside of the rotor, what will happen. So inside of the rotor, the motor at what angle it will be rotated, whether 0 degree how the motor is going, and 60 degree or 120 or 180, 240, 300 or 360. So depending on the rotation, the motor rotation, and by giving from the motor to feedback path, we are giving to the inverter topology. Inverter topology, we are giving the feedback path. Then how we are commutation we are doing, and how we are decoding the permanent magnet sensor signals to electrical signals. We need to give the gate signals to, right? We need to give the gate signals particularly to the power electronic switch. Switch 3-phase inverter we are using. We can't turn on at a time in a single leg. We can't turn on 2 switches at a time. If you are giving, if you are suppose the pattern, how the pattern will be 1, 3, 5, 2, 6, 4, right? If you are operating 1 and 4 at a time, the switches in the same leg, if you are operating both switches, means it will go to short circuit. So definitely at a leg, one leg, you can operate only one switch, whether it is upper leg switch or lower leg switch. So compulsory at 2. So that's the reason in a 3-phase inverter, how many active vectors, how many zero vectors means the possible vectors are to convert the DC into AC means 2 per general formula is 2 power n. That means 2 power 3 means we have 8 active vectors are there. In that 8 active vectors, the 2 are zero vectors and the remaining 6 are active vectors. So those 6 active vectors, through that 6 active vectors, we can convert the DC supply into the AC supply. Then we can give to the PMSM motor. That PMSM motor, from that PMSM motor, we are giving the feedback path to our vehicle also. So we are giving the feedback path to our motor also, right? So here I will show that machine. So it is taking delay. Just a minute. So those permanent magnet synchronous machines. So here we are giving the feedback path controller, PI controller, we are giving the feedback path. And here if you are observing the 3-phase inverter also, A phase, B phase, C phase, they are maintaining with the 120 degree, 120 degree. So we have 3-phase inverters, we have 2 types, voltage source converters are there and the current source converters are there. And again voltage source converter, we have 180 degree conduction mode and 120 degree conduction mode type of inverters also there here, right? So from here we will see that model. Voltage source converter and 120 degree conduction. Here we are using the 120 degree conduction mode only. By using the 120 degree conduction mode, how we people are giving the switching signal to the converter top. AC type of converter topology, how we are giving the gate signals. Through that gate signals, so how much magnitude you are giving, how much magnitude you are giving the B phase, how much magnitude you are giving the C phase, right? So you are giving the DC magnitude, it is around whether single phase or three phase means you will give 230 or 400 you will give. So according to that, how it is converting. That DC supply, DC means it will be unidirectional power flow, but when you are converting the DC into AC, you will get the pulsating type of AC only you will get. When you are adding the filter only, you will get the pure sinusoidal AC waveform, right? So again, it is a somewhat little bit drawback. If you are giving the more voltage distortions in your machines, so suppose if you are giving the more distortions are there when you are giving the input power supply, so then again it will take some so much time, and the long life of the product also it will be reduced here. Here we will see. So the Matlab taking so much time. Yeah, you can see here. So this is a closed loop control of a, you can see here. So this is a three-phase inverter which we are taking the 6 switches and we are giving the controlled voltage source we are taking, right? By using the controlled voltage source, we are giving the one feedback path from here. This is the feedback path of our motor, right? You can observe here. So this, how many switches? 6 power electronic switches we are taking. Then we are taking one three-phase voltage measurement block we are taken. Then we connected here one permanent magnet synchronous machine we are taken. So by taking the permanent, you can see here. So 6 switches. So from here, by taking the controlled voltage source, how much DC voltage source we are taken here inside for this DC input voltage is, here we are taking one control voltage source, right? In this control voltage source, we are given the DC input voltage. Then we are converting by using this inverter. Initial DC source we are giving here. You can see here. So here, by using this one, so these 6 switches, we are controlling the this PMSM machine. So inside of the PM machine, if you are observing, a permanent magnet synchronous machine we are taking from the library only. From that permanent magnet, what are the parameters we are taking? So, and the stator phase resistance, it is around 14.58 only, and the stator phase inductance is, it is around 25.71 e power minus 3, and the back EMF, if you are observing, 120 degree only it is running, and the voltage constant, it is around 51.8384 only we are giving. And here the configuration parameters we are observing, the number of phases we are taking 3 phases, and here we are choosing the back EMF waveform is trapezoidal torque Tm we are selecting. Degree rotor flux position we are taking here. So then here when I am connecting a bus selector here, when I am connecting a bus selector here this is a bus selector. When I am connecting to this measurement port, automatically inside of the permanent magnet machine, so this is permanent magnet machine I said, right? So inside of that permanent magnet machine, so what we are taking, so I said inside of the rotor positions you need to identify, means compulsory you need to take the Hall effect sensor signal. Inside of the rotor we are placing the Hall effect sensor signals. Through that sensor signals only we will identify the rotor positions. So here you can see here Hall effect signal HA, HB, HC we are taking. We have the stator currents, rotor path currents, and the stator HA, Hall effect signal HA, HB, HC we are selecting here. By selecting these Hall effect sensor signals, we are given to this one. So here we are giving the decoder we are giving. So now from here in this decoder, this is purely designed by this one. So by using the digital electronics, AND gate or gate operations, you people will know well. So here what we are telling, from the HA, HB, HC, Hall EMF sensor signal HA, HB, HC, we are converting that one into induced EMF A, B, C. So as I said, so we have 2 active vectors. That means 6 active vectors, 2 are 0 active vectors, right? So from here first one and third one, then both are will be 0. Suppose in a 3-phase inverter, if you are observing here, if you are operating these 3 switches, if you are turning on these 3 switches, it will go to open circuit, right? So that means upper leg switches if you are turning on, means it will goes to 0. If you are turning on lower leg switches only, if you are turning on only lower leg switches, it will also go to open circuit only. So there is no power flow. So whenever you have one closed loop on, then you can get the power supply, right? So you can convert the DC into AC here. So here we are giving the feedback path to here. By using the PI controller, we are trying to control the speed of the motor 2500 RPM. So in this decoder, how we are done means, so this 001, you can take anything. So whether 001 if you are taking, HA, HB, HC you are taking, right? So from the HA, HB, you will get the induced EMF A. Induced EMF A you will get. HB, HC, you will get the induced EMF B. HC, HA, you will get the induced EMF C. How you will get, means suppose, take an example 010. Suppose first you are taking the HA, HB. You can write from your notebook HA, HB. You can write initially you need to write HA, HB bar you need to write. Then again you need to write HA bar, HB. What is HA? 0. HB what? 0 bar, right? HB bar means 1 bar you will get 0 only. So from 0, what is the AND gate operation? If you are giving this input to the AND gate, here we are giving the AND gate 0 HA, HB bar, we are giving the input to the AND gate operation. What will happen? AND gate operation, whenever 1 only AND gate operation, output will be 1. Remaining time it will goes to 0 only, right? So here we at one case we will get 0. Then again we have HA bar, HB we have, right? What is HA bar? What is HA bar? HA bar you can see here. HA bar we have. HA bar, HB we have. What is HA bar? 0 bar. What you will get? 1 you will get. What is HB? Here HB. 1 only we have. From 1 you will get output is 1 only. But what you are doing here? Here HB bar you will get here 0. And here you are getting 1 you are getting. So then if you see here, upper side one you are taking 0, lower side one you are taking negative, right? So 1 you are taking, that means -1 you will get the output side. -1 here you will get the output side. So the induced EMF A, here -1 you are getting. For induced EMF B, HB, HC, you can see here HB, HC bar, then again HB bar, HC we are taking. What is HB? HB is 1. HC bar means 0 bar. 0 bar 1 you will get, 1 1 you will get output 1, and here HB bar 1 bar 0, HC already 0, 0 0 you will get the output 0, and HC bar here 1 and here 0. Upper side 1 you can see here. Here you will get 0, here you will get 1. So 0 plus 1 is minus 0, you will get the 1 only. You can see here plus 1 only. So like that we are taking this truth table, we are designed this model. So then we are giving the electronic commutation, gate signals we are giving. So switch will, upper leg switch will on means lower leg switch will be off, lower leg switch will be on means upper leg switch will be on here, greater than 0, less than 0, greater than, that means you need to turn on at a time one leg you can operate only. So you can't turn on the both legs at 2 times. So here I am running this Simulink model. We will just observe the output waveforms of VA, VB, VC, then the speed of the motor we will observe here. So you can check here. Here we are giving the reference speed, we are giving the 2500 RPM. 2500 RPM only we are giving. So this 2500 RPM we will see here 2500 RPM we are giving. So it is after finishing the compiling it will be started to run. So for simply understanding this decoder technique from 0 to 7, the truth table 8421 BCD code. BCD code. According to that BCD code, we can design that one. You can see here it is started to compile, and here we are controlling with the motor 33% it is running, right? 55. So then we will see the output waveform. You can see here. So you are giving the feedback path. So that feedback controlling technique we need to use. So if you are observing the speed of the motor, so when initially it is started will be 0, then it will go to some peak value and it will be settled down here. We will see here. We will see the outputs, how we are getting, we will see here. You can check the speed of the waveform here. You can see here it is started from 2500 rpm, right? So the constant speed only it is going. So if any distortions are there, so if when you are giving the inputs power supply, if you have the distortions, mean the check here, you can check the VA, VB, VC also. VA, VB, VC also you can see here. From VA, VB, VC we will see here. You can see here A phase, B phase and the C phase. You can see here voltage VA, voltage VB and the VC. Pulsating AC output was only we are, right? So if you need the pure AC sinusoidal waveform means before the motor you need to connect one LC filter. So you can see here one is started from negative, one is started from the positive and another one is started from the zero only. When you are getting a zoom, you can do that. We can do that one. Here we are giving the 200 AC input to the motor only. 200 AC input voltage we are giving to the motor here. Apart from that, fact controller techniques means in that fact controller techniques we have series shunt. So normally, generally we will get the so many power quality problems. So power quality problem, whether voltage transients or voltage sag, voltage swell, harmonic distortion. And for any power system network, we have the power system network. It is a big network. So we have generation, transmission, distribution, and utilization of the grid we have, right? From when we are generating the power, through that we are transmitting the power, right? So by generating the power in a transmission line itself, almost 20 to 30% of the losses every year we are getting. In India, 20 to 30% of the power losses will be happen when we are transmitting the power losses. That means the people who are taking that one due to the transmission network, the conductor line, they are not maintaining quality of the conductors, and when it maybe somewhat damage will be happen, right? So due to the I said voltage sag swell problem, during the rainy season we may get heavy rains or trees may fall down the transmission lines, or due to the lightning strike occur means lightning strike occurs means the transmission network may be damaged. So at that point, the symmetrical faults or unsymmetrical. Unsymmetrical faults will be created. LG fault, double LG fault, triple LG fault, or triple line to ground faults will be created, right? So this voltage sag or voltage sag, mainly voltage sag will be occur due to the lightning strike or short circuit faults we can call. These voltage sag problems we can call it as a short circuit problem also. And at some time long interruption will become. So in voltage interruption also, long interruption also will come. But this voltage sag swell problem, it will be fraction of seconds only. Within the fraction of second, it will be reallocate, and again the system become more stable. But these controllers, whatever the controllers, whatever the problems we are telling, voltage sag swell problems, it may affect on the power system network. Suppose if you are occurring when the swell problem will occur, means suppose when you are using at your domestic application, you are using single phase supply. Suppose if you are using more number of loads, automatically the loads when you are increasing, automatically that burden will come onto the power system network. So then normally sinusoidal waveform means pure AC it will come. Suddenly it will be raised some, it will give some jumps. That means Normally if you come to 30 means heavy voltages will become. So at that point, at load side, whether your laptops or electronic gadgets or your domestic load application, whatever the loads you people are using, they may damage. So to protect our load equipment or to reduce the harmonic distortion, to overcome all these power quality issues. So when we are transmitting the AC power means to control the AC magnitude, over a magnitude, number of phases, and the frequency variations also will come. So normally in Indian grid connected system, we are using the 50 Hz frequency only. So that means plus or minus 5% means it will be okay. 49.5 or 50.5 means it will be okay. Suppose the frequency variation suddenly it will come to 40 or it will goes to 60 means at that time grid may collapse. We are already faced that problem few years back. Northern states, north grid will be collapsed and entire North India goes to in dark situation, right? So we need to protect, we need to monitor the all these issues. So for that reason, the researchers and the scientist people, they are implementing the fact devices. Those fact devices also they are implementing by using the power electronic devices only. So whether it's a shunt active filter, series active filter, hybrid active filter, and both combination of series and shunt we can call UPKC, unified power quality conditioner, and UPFC, unified power flow controller, and DSTATCOM, so dynamic voltage restoration. All these fact devices will improve the power quality. And whenever you people are using this DVR or shunt active filter or DSTATCOM before the load side, before the load equipment, when you are using these fact devices, they may protect if any disturbance system network also. These fact devices will protect the load equipment. If you are observing any data centers, if you are observing any data centers, in those data center they have sensitive devices. If you observe emergency equipment, that means where we are using the emergency equipment in the medical hospital. So those hospital they need 24 by 7 power supply they need. If any interruption occurred in that hospital, mean it will be effect on the patients, right? So then we need to monitor the power supply always. Power quality we need to give. So for that reason, these power quality device, power qualities or power converter topologies will give effectively, and it will work and it will improve the power quality. These devices we need to place before the load side equipment. Load side equipment we can protect all our loads which we are using in our domestic loads also. But these devices somewhat costly. So apart from this, DVR will be cost wise it will be very less. So we can prefer to improve our power quality. These devices we can utilize. I hope you people get some points, key points for attending this session. So each and everyone for participating in this session, for spending your valuable time in our this session. So thank you all. So thanks to participating in this session. I hope everyone subscribe our channel. We will every day we are updating with the new technologies. You can get those things. You can subscribe our channel and you can go through that one and give your valuable feedback, and it will be give some boost up. So thank you all. Have a nice day. Stay home. Stay safe. For further information, you people can contact Senthil sir, Srinivasan sir, and Kumar Swami sir. So you can subscribe the Pantech e-learning YouTube channel. So thank you all. Have a nice day.